So let's take a look at an example. Let's sketch the graph of a line expressed as a vector equation in 2 dimensions. Okay. By the way, I look at this and I know immediately it's a line because it meets the form. Okay. The form that we had was some point on the line plus t times a direction vector. And so we meet that exactly, right? This is some point on the line. This is a direction vector. And t is the variable. So we are in 2 dimensions. Now I just want to re-emphasize these equations. They don't work for just 2 dimensions. They work for 3 or 4 or 5 or any number of dimensions. But it's much easier to visualize and draw it out for 2 dimensions than it is for higher dimensions. So we're going to start our examples here in 2 dimensions. Okay, so if we know the form of the equation of the vector equation of a line, it's very straightforward to draw this out because we know this is a point on the line, 3, 2. So 1, 2, 3 on the x, 2 on the y. There it is, 0.32. Okay? So we know that point is on the line. We also know that this is a direction vector. And so from this point on the line, if I move in the direction of the direction vector, I should be pointing in the direction of the line. So I'm going to go, the direction vector is 2, -3. So 1, 2 right, and 1, 2, 3 down. Okay, that's our direction vector, which means the line is pointing in that direction and going through that point. Okay. If I want to, I could draw arrows here. The arrows usually mean vectors, and I want to differentiate that from a line. But it keeps on going, right? It doesn't just stop where I've drawn the stop. It's an infinite line. Okay, so that's the equation of a line. And I want you to be convinced of this, so let's plug in a couple points just to get a feel for what's going on here. Let's plug in -1/2 into t. So if we do the vector arithmetic, plugging -1/2 into t, you know what, I'll just do it all at once. 3 plus -1/2 times 2, that's 3 plus -1. That's going to be 1. I'm sorry, that's going to be 2. 3 plus -1 is 2. And then 2 plus -1/2 times -3 is +3/2. So 2 plus 3/2 is 7/2. Okay. And so if I find 2 7/2, so 2 is right here, and then 7/2 is 3.5. There's 3, so 3.5's right here. That gives me my point right here. Okay, and it's on the line, right? And it is opposite the direction where our direction vector is pointing, but it's only half as far in the reverse direction because the scalar is -1/2. Okay, negative, so we flip the direction, and half, so it's half as long in that direction. Okay, any value of t you plug in will be on this line. I've given you one example. The line is all the possible values of t that we could plug in.